Well, I've got the M1 paper, the old specification, 2016 question 5, inclined plane question. Right, we've got a particle P, mass 2 kilograms, held in rest, in equilibrium on a rough plane, constant force of magnitude 40 newtons, which is an angle of 30 degrees to the plane, and the plane's an angle 20 to the horizontal. So it's all a bit different. The line of action of the force lies in the vertical plane containing P, the line of greatest slope. You don't need to worry about that line. It just means it's going straight up the plane. It's pushing it right up the sort of the steepest part. So we can use those angles. Coefficient of friction is mu, and it's on the point of sliding up the plane. And that means the friction's acting down. So the 40 is just about big enough to make it move up the plane, but not quite. So like I say, the friction's acting down the plane, and we've got to find out what mu is. So we'll draw the forces on. We've got the 40 there, the weight acting down 2g, the friction, like I say, is acting down the plane, and then we've got the normal reaction R, and we've got to find out what the mu is. So we're going to look at the forces parallel to the plane and perpendicular to the plane. Parallel first. Look at the 40 now. Now that's trying to push the particle up to the right. I've got to turn it through that angle. That angle's 30 degrees, Z angle, alternate angles if you like. I've got to turn it through an angle of 30 degrees there. So the component in that direction is 40 cos 30. What else? We've got the frictions. That's going directly down the plane. So that's in the opposite direction. So the 40 cos 30 is equal to the friction. And also we've got the 2g trying to make it go down the plane. I've got to turn that through an angle of 70 because there's a right angle triangle there. That angle's 70 degrees there. So I've got to turn the 2g through an angle of 70 degrees. I've got to multiply it by cos 70 to find the component parallel to the plane. So the friction plus the 2g cos 70 is what the force is making it go down the plane. And that's going to be equal to the 40 cos 30, which is making it go up the plane. Look at the forces perpendicular. Well, there's one force going up to the left. That's just the R. There are two forces that are trying to make it go down to the right. That's the 40. And we want the component in sort of the perpendicular to the plane direction. That angle's 60 degrees there, because the other one was 30, so I've got to turn it through an angle of 60 degrees. So that's 40 cos 60. And then finally, the 2g, the weight is trying to push it into the plane. So it's got a component perpendicular to the plane. That angle's 20 degrees because the one next to it, this angle here was 70 degrees. So that's 20. So I've got to do times it by cos 20. So the R, which is going up to the left, is equal to the 40 cos 60, which is going down to the right. So into the plane, plus the 2g cos 20, which is also going down to the right. And I've got to find the coefficient of friction. I'll use friction is equal to mu times R, because it's in limited equilibrium. So the friction, if I rearrange the first equation to say friction is equal to the 40 cos 30 minus the 2g cos 70. The mu then, I can rearrange this, friction over the R, 40 cos 30 minus 2g cos 70 is the friction, and then the R on the bottom. Stick that in the calculator, and I get 0.727, and there we go.